Over the past half-century, scientists have amassed a vast amount of information about the universe, including data about the solar system and its objects, as well as about the distant cosmos. Much of this work has been accomplished by space probes. Without them, astronomers would still be speculating, for example, about what Europa, Jupiter's moon, or the surface of Pluto look like. Voyagers, precisely such spacecrafts. They have become reliable instruments for exploring space and have been serving humanity for almost 50 years now. Unfortunately, nothing lasts forever, and one of the twins is currently facing serious technical problems that are unlikely to be resolved. So in this video, you'll learn about what they've studied, what's happening now, and what lies ahead. Hello, dear friends. As you've already guessed, today we're talking about the Voyager spacecraft. But before we dive into this topic, we'd like to ask you to subscribe to our channel and hit the bell icon to be the first to see our new interesting videos about the mysteries of the universe and our planet. The Voyager project is one of the most remarkable experiments conducted in space in the last quarter of the 20th century. The giant planets are too distant for ground-based observation, so the images captured by the Voyagers in the vicinity of these planets and the measurements they made still hold significant scientific value. But let's start from the beginning. The idea of the project first arose in 1966 when a student intern at the University of Tennessee Space Institute, Gary Flandreau, published a scientific paper on the possibility of reaching the outer planets using a gravitational maneuver near Jupiter. In his work, the future scientist noted that in the late 1970s, there would be a favorable opportunity to fly past 4 giant planets of the solar system simultaneously, thanks to rare alignment in their orbits. 3 years later, based on Mr. Flandreau's work, NASA introduced an ambitious project called the Grand Tour, envisioning the sending of a pair of spacecraft on trajectories past Jupiter, Saturn, and Pluto, and another 2 past Jupiter, Uranus, and Neptune. However, due to the high cost of the project, the agency couldn't secure sufficient funding to execute the entire project. Uranus, Neptune, and Pluto were officially excluded from it, and the number of launches was reduced to 2 spacecraft of the well-proven Mariner class. Preparation of the spacecraft for their journey into space began. Unlike the Mariner probes, which studied the inner planets, the Voyagers couldn't use solar panels because as the spacecraft moved away from the Sun, the solar radiation flux became too weak. For better understanding, near the orbit of Neptune, it is approximately 900 times weaker than at the Earth's orbit. As a result, it was decided to equip them with 3 radioisotope thermoelectric generators fueled by radioactive plutonium. In addition to the change in the power supply system, each Voyager was equipped with a golden record encased in a round aluminum box. There were 115 images on it containing crucial scientific data, views of Earth and its continents, scenes from human life, as well as our biochemical structure. In addition to this, necessary explanations were encoded in binary, and the location of the solar system relative to 14 powerful pulsars was indicated. Human speech was represented on the disk by short greetings in 55 different languages, as well as works of Bach, Mozart, Beethoven, and folk music from many countries. After thorough preparation, Voyager 2 departed Earth first on the 20th of August 1977, while its twin followed closely behind 16 days later, on the 5th of September 1977. Both spacecraft embarked on different trajectories, which helped them both make history in space exploration. The Voyager 2 mission initially included the exploration of only Jupiter and Saturn, as well as their moons. Despite the spacecraft's service life being set at 5 years, its flight trajectory also allowed for the possibility of further movement toward Uranus and Neptune. A spoiler alert, this possibility was successfully realized. In July 1979, the spacecraft approached Jupiter. Voyager 2 came close to Europa and Ganymede. The transmitted images gave an idea of the composition of the moons, as well as allowed for the hypothesis of a liquid ocean beneath Europa's surface. 2 years later, in August 1981, the spacecraft approached Saturn and also passed by Tethys and Enceladus, transmitting detailed photographs of the moon's surfaces. At this point, Voyager 2's journey was supposed to end, but due to its excellent technical condition, it was decided to send the spacecraft towards Uranus, which it reached on the 24th of January 1986. Voyager sent back thousands of images of the planet, its moons and rings. Images of one of the moons, Miranda, astonished researchers. It was initially assumed that small moons cool rapidly after their formation and represent a homogeneous desert. However, it turned out that Miranda's surface features valleys and mountain ranges, among which rocky cliffs were noticeable. After completing its exploration of Uranus and its surroundings, Voyager 2 set course towards Neptune. On the 25th of August 1989, the spacecraft flew within 48,000 kilometers of the surface of the last gas giant. If it hadn't been for the fortunate opportunity identified by Gary Flandreau, the journey to Neptune would have taken 30 years. However, Voyager 2 accomplished this task in just 12. The spacecraft sent back unique images of the planet and its large moon Triton to Earth. Geysers were discovered on Triton, which was very unexpected for such a distant and cold moon. After his last resort, Voyager 2 headed towards the edge of the solar system, reaching it almost 30 years later. On the 10th of December 2018, NASA confirmed that Voyager 2 had entered interstellar space. However, the probe still remains within the bounds of the solar system, as its boundary is defined by the outer edge of the Oort cloud, which the twins will reach at best in several thousand years. Voyager 1's mission differed slightly from its twin. A shorter route was chosen for it, allowing it to overtake Voyager 2 between the orbit of Mars and the asteroid belt. The probe reached Jupiter several months ahead of its twin, then visited the vicinity of Saturn in 1980. Immediately after, the spacecraft headed towards the edge of the solar system. On the 17th of February 1998, Voyager 1 became the farthest human-made object from Earth, surpassing Pioneer 10 at a distance of about 10.5 billion kilometers from the Sun. Then, on the 25th of August 2012, Voyager 1's sensors detected a sharp decrease in the number of particles and cosmic rays associated with the heliosphere, along with an increase in the intensity of galactic cosmic rays. Voyager 1 officially entered interstellar space. Unfortunately, in recent decades, the probes have been operating on what's called running on fumes as the power from the thermoelectric generators continues to decline. More and more technical problems arise, making it increasingly difficult to solve them. For example, in 2017, Voyager 1's primary engines began to fail, and Earth attempted to activate the spacecraft's trajectory correction engines for the first time in 37 years. Surprisingly, the launch showed that everything was fine, suggesting an extension of the spacecraft's service life by another 2-3 years, and ahead of time, it turned out that the engineers were right. However, in 2022, serious issues with transmitting telemetry from Voyager 1 began. The spacecraft started sending strange data about its position, a sequence of zeros or 377. It turned out that due to the impact of harsh radiation on navigation, the spacecraft's attitude control and maneuvering system had malfunctioned. It took some time, but scientists managed to solve this problem as well, but not for long. In December 2023, the situation repeated itself. The telemetry modulation unit started sending a strange binary code to the control center. Scientists rebooted the system, but to no avail. The probe continued to transmit incomprehensible data. As of today, NASA is working on restoring the probe, but the chances of success are very slim. Susanna Dodd, the mission's leader, says that bringing the spacecraft back to life would be the greatest miracle. How sad it may be to admit, it seems that Voyager 1's days are numbered. But not everything is lost. The twin probe Voyager 2 is still operational. In 2023, its service life was extended for several more years. In particular, scientists solved the problem of the fuel element's power drop by disabling heating systems that are no longer needed to maintain flight. As the spacecrafts travel farther away, they continue to transmit increasingly valuable information, so NASA is very interested in continuing their work. Voyager 2's systems are currently functioning stably, and there are no critical failures so far. In early 2023, scientists analyzed the data from the probe. It turned out that everything was going according to plan. We will hope that the Voyagers will continue to operate for several more years until the fuel element's power is finally exhausted, so that we can learn even more interesting things about space. Perhaps one day, one of these probes will become a starting point for interaction with other civilizations, but that's a completely different story. Thank you very much for watching. If you enjoyed this video, don't forget to like it and subscribe to the channel so you don't miss out on new intriguing videos about the mysteries of space. Write in the comments what you would like to learn about next time. Thank you and see you next time.